Hey, there we are. Good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. This is the Visual Studio channel. My name is Jeff Fritz, and welcome back to episode 5 of C# with CSharpFritz. It's a beautiful day outside. It's an amazing day to learn about technology, and I hope you stick around with me for the next 2 hours. We're going to talk about generics. We're going to talk about lists, collections, arrays. We're going to learn about all those things here in this talk radio style format discussion about cool features in C# that you can interact with. You can learn along with me using a Jupyter notebook. Before I get too much further, let's say hello to the folks that are over there in the chat room. There they are right there. Hello. Aztec Consulting, Santa Claus 7. It's a little bit early, Santa, but good to see you. Hello. Wrong channel? No, we're right here on the Visual Studio channel. I normally broadcast on the CSharpFritz channel, but today we're over here on the Visual Studio channel teaching all about .net. Let's say hello to, is that Freljung? Ahoy the stream. Absolutely. Shy Sharp is here. Mao Codes, good morning to you. Calibron, good morning as well. Good afternoon to GL Conti. Adria, is that Adrian 1? Hello to you in Belgium. So good to see you. Thank you for tuning in. SmartCod, hello. Good morning to Eggsy. And good morning also to our Microsoft friends in chat. Tail Learn Code is here. Good morning to you. WQ Walter in East Tennessee. Can we get a quick sound off where different places folks are from? You don't have to be specific, but East Tennessee, Belgium. Can we show some of the places that folks are watching from? Nothing else matters. From Bucharest. Oh my goodness. Montevideo, Uruguay is that Visigotan. Very cool. Dallas Fort Worth is where Aztec Consulting is. Is it Wyandis 4? In Eastern Tennessee, Portugal or Portugal? Is that what you meant to say? Northern Hemisphere is where El Greco 17 is hiding. Can't find him in the north somewhere. Florida. There we go. Nelson's in Portugal. Very good to see that. Welcome in Turkey for Eloquent. Oh, very nice. Arizona for Eggsy, early morning, and that's for folks here in the States. I kind of like that, having that morning together and being able to hang out and talk. Very cool stuff. Thank you so much for tuning in, friends. So today I want to talk about collections. We hinted at this last time in episode 4. The videos, of course, are available out on the YouTube channel, youtube.com/.net, and you can find the C# with CSharpFritz playlist there. If you click through, you'll see last time we hinted a little bit at collections as we went through loops, whether it was a for loop or a while loop. We even did foreach loops, and we started to hint at the concept of a collection. So what are collections? How do we work with arrays and different shaped arrays? And what's a list? What's a dictionary? There's other things out there we can interact with also called stacks and queues. And what's this whole generic thing? I keep seeing angle brackets around some types. That looks a little weird. So we're going to talk about all of those things. We're even going to build our own generic collection together. And if we get there, I'm going to keep an eye on the time. If we get there, we might sneak into a little bit of LINQ, and we can talk about that. But I have LINQ planned for next week. We might sneak in and get into a little bit of it. Let's see how it goes. El Greco likes the hat. You like the Xbox hat? Yeah, our friends on the Xbox team, they're going to be launching a new version of their device coming up in November. You can pre-order, they say, on their website if you want to get in line so you can get yours early. That's pretty cool, and I want to support my colleagues that work on the Xbox team. Hello to you, Nash in California. Good to see you. So let me get some music playing in the background here. This is these are stream beats from our friend Harris Heller. These are songs that are high tech, they're tech music, kind of groovy in his synthwave playlist that we're going to play in the background. We can listen to because he's made these available royalty free, streamer friendly. They're suitable for your Twitch streams, for your YouTube videos. And he says, late night DeLorean rides. Okay, that's great. So let me get those playing in the background. This is, there we go. Just a nice little bed in the background there when we go quiet. Pre-orders start on the 22nd. Thank you, Cymac. Appreciate that. So, let me head over to the code. Let me show you the GitHub repository for the project and how you can get started and interact with some of this code live. Let me head over there and we'll take a look-see. This is my GitHub repository that we're using for everything that goes along with this series of shows. Whether it's different notebooks that we're working on, configuring how they can run out there on Binder is the service that we're using, so you can use them in the browser. And if you want to ask questions, there's issues here that you can open up, comment on, and interact with. And you can also see the schedule of upcoming shows under the Projects tab over here. There's information here about how this runs, because some folks aren't familiar with how you can run .NET in a Jupyter notebook. So there's instructions about how you can get that configured if you'd like to interact with that as well. Information about the community and the license for all the content, all of the lessons, all of the source code that we write together here on this video. It's all free for you to use. It's MIT licensed for you to be able to interact with, share, show off, reproduce in front of your user group, or maybe with some of the folks that you work with, some of your friends, whoever it might be. So this is session 5 we're going to go into. I've been trying to launch Binder this morning. I've got all the things recompiled so that it'll run out there. Those folks that are watching this live, Binder's having a hard time starting the container. It starts up and just kind of hangs here. And I'm not sure what's going on. Hopefully those of you that are watching the recording, this issue is cleared up and it'll launch for you right away. If you want to follow along with me, you can clone the repository locally and just run a docker compose up command, running Docker on your local machine. And it'll start and you'll be able to interact with the notebooks. Otherwise, sit back and I'll talk through these notebooks, answering your questions along the way here. The AMA tag is live if you're watching on Twitch. Any question about C# or collections that we're working on today, I'm happy to answer. We'll bring up with a little tag that you see appear on the side of the screen over there. Other questions about .NET, about Microsoft, and other things are off topic. We will not be discussing them today. Root, is that Root KK? Good to see you. Hello. Thank you for the hi guys emote there in chat. So let's start talking about. I didn't want to jump over to .NET Interactive. Let's start talking about generics and collections. And I'm going to get to generics a little bit later on. This is a larger notebook, and there's a whole bunch of things happening here that I want to make sure that we talk about, because this can get to be a little bit confusing, because there's a bunch of moving pieces here, and there's a handful of different types that we're going to talk about throughout the stream, throughout the video today, and I want to make sure that I answer your questions. So you can see the other 4 previous notebooks that we've worked on are right there in the file list on the left side, and we're going to start off talking about arrays. Now, collections are ways that we can group together, right, a group of different instances of types, right? Everything in C# is an object. So an array is another type of object. It's a reference type, if you remember back to our discussion about reference types and value types. Well, an array is a reference type, and of course, I've provided links to the official documentation that you can click on here. And you declare an array, a collection of objects, by using a square bracket notation you see here. So here in this sample, I've declared a collection of numbers. So I define, here's the type of the array that I want. I want integers in this array, and integers that make up a collection an array that we'll call numbers. Now, I've also put together some little tests here that'll show you, and let me not show the next section there. I want to show just this part. when you just declare the object, it's created, but there's nothing in it. It's actually null. It's allocated memory for it, but it hasn't actually put anything into that yet. You have to assign a collection to it. So you see here in this next block, I'm going to assign it, and inside those square brackets, you define how many elements you want in that array. So now it's created, it is not null. So now I have this array is created false is output here, right? Let's change this to array is not null, and I'll rerun that. And you see it'll say array is not null, false, much better. There's properties that you'll find on all of the collections like length that'll show you the number of elements in the array. It's not the size of that dimension, but the number of elements in the array. So there's 3 elements in the array that we've allocated. There aren't necessarily things in there, but because we've declared an integer array of size 3, we've allocated 3 elements. And now if I want to declare it and set some initial values into it, I can use curly braces like I show here, and I still end up with an array of size 3, but now it's actually got stuff in it. So whether you actually put things into it or not, that array is 3 elements wide. That's interesting. That gives us a hook here. That's something that we need to be aware of. So, how we doing there, chat room? I see a bunch of folks out there, and chat's going a little bit quiet on me. I want to make sure. Yeah, array is not null, false. Oh, you're right. Let's change that to. Let's change that text so it says array is null, false. There we go. Hey, John Calloway, good to see you. Thank you for the pointer there, .net know-how. Got that text fixed properly. So next, if I want to start interacting with those elements in the array, we have a base value of 0. Our indexer has a base of 0. So if we want to start fetching and interacting with values in there, well, I can say item 0 by accessing, right? Full array of numbers is the name of this array I created here at the end. So if I say full array of numbers 0, well, that's going to give me the 0 with item right there and return it. I can set values in the array after the fact by using the equals assignment operator and assign, let's say, the value 5, and you see now it's assigned. Item 0 is now the value 5. Okay, fetching and retrieving from an array, big deal. This is very basic interaction. And of course, you can't interact with array values that are outside the size of the array. So there's only 3 values in here. If I try and access the 5th item, right, the item identified by indexer 5, which actually isn't the 5th item, it's the 6th item, I stand corrected, and I control enter there, you see I get an index out of range exception. Clearly, the index was outside the bounds of the array. You can't access the 6th item when there's only 3 in the array. Makes sense, right? That's kind of par for the course. You expect this, right? You can't do things with that. Similarly, you can't assign values to that either, right? If I say full array of numbers 5 equals whatever value here, and I try and access it again, comment that out, it's outside the bounds of the array. You can't just all of a sudden say, oh yeah, there's a value way out there, when the array is clearly only 3 elements wide. So the array is a fixed size. It doesn't dynamically resize when you start assigning values to it. Other programming languages, other frameworks do allow you to dynamically resize the array by just assigning values into a new index, and it suddenly makes it that size. Doesn't work that way with .NET and C#. These are statically typed languages. This memory must be allocated for you before you start interacting with it. Hey there, is that .commie? Hello, hello. Atlanta Jose, good morning to you. I hope everybody's doing well out there, especially our friends on the West Coast with some of the fires that are going on around Portland, Northern California, and the Seattle area. Hope folks are staying safe and doing well. Now, these are one-dimensional arrays. Well, what if I want to have a matrix, right? If I want to have a multi-dimensional array, you can do that by defining additional dimensions separated by commas when you define the size of the array, the initial bounds, right? So now I can initialize by using curly braces in for each, what would be each row in it, right? This is the number of rows, the number of columns, right? And it would be each dimension going along. So I have 1, 2, 3, 4, 5, 6, and you see that is 6 elements inside that multi-dimensional array. And you then access the elements of the array, just like I put a single digit there inside of brackets in order to access that element in the array. You can access them with 2 indexers for each one of my 2 dimensions. And you can go many different dimensions here. I forget the limit on the size of this. You can check the number of dimensions that you can go through. But you can certainly check through the official documentation to get more about that. Let me say hello to, is that LK you say? Hello to you. Welcome in. Appreciate new folks joining chat and saying hello. So, multi-dimensional arrays, very similar to what we've already got there. Paris Seneca, hello to you. Welcome in. Now I mentioned this part here, right? You can't easily resize or remove, right? You can't expand or contract the size of the array. You need to go through a little bit of reallocating of that. And there's a method on the array object, a static method on the array object called resize that'll help you do that. So let's take a look. If I have my numbers and I allocate a new integer array of 1, 2, and 3, I'll display, there's my numbers 1, 2, and 3. I can't just add to it and have it resize it, but I can use this array resize method and tell it, here's the new number of elements in the array. We're going to go from 3 to 4. Also, notice when I declared the size of this and the shape of my array up top here, I didn't provide the limit as to the size of this. I didn't specify, and I don't need to specify that 3 when I'm initializing my array, right? If I'm providing initial values here, you don't have to give it that number of elements. I can make it larger than that number. Okay. And you would need to provide the number of initializers appropriately. But they have to be equal size, or it'll... I've gone too far. I've hit the backspace when I shouldn't have. Down in here, where was I? Over here. Or you have it dynamically allocate, and it'll set up that array with the appropriate size. The array resize will appropriately take that array, and here it is with that ref keyword that we talked about a few streams ago, a few videos ago. It'll take that array and by reference change the size of it and now make it 4 elements, and I'll be able to access what's now the 3rd element by indexer and change it. So now you see I've resized my numbers to 4, and I've set element number 3 with indexer 3 to the value 4. Where clearly just above here it was only 3 elements. So we've set this up to allocate appropriately that extra space. I can remove elements also here by reducing the number from 4 to 3, and you'll see it removes elements from the end of the array. And there we go, it does that. There's a question in the chat room from Black Eye, asks, what's the fastest way of initializing an array with the same value? You know what, this isn't something that I've done frequently. I feel like doing this with a for loop to go through and set all the values is the wrong way to do it. I feel like doing this with setting these values all the same like that is kind of a pain, especially if you have many different values there, many different elements there, right? If this is 100, I don't want to have to sit here. That's a pain in the neck. I don't want to do that. I feel like there's a quicker way to do this. And if we click through to the official documentation, I believe there was a way to initialize, besides setting element values. We're going to talk about a jagged array. But I thought there was a way to initialize these. I would have to go digging for it. I'll find that documentation and I will add a line here about initializing. There is a way to initialize this quickly and I forget what it is. So I would yeah, let me come back to that and I'll have an update there. Now, arrays, like all of these collections, implement the IEnumerable interface, meaning we can enumerate the collection. We can go through it and we can output values. So I can use things like the foreach and create a loop here very easily to say, give me each one of those values. Now, the I value that it's receiving here is not the indexer, right? In other languages, you can have it return the indexer from the array, not the value. This for each will give you the element of the array. So you can iterate over the contents of a collection with a loop, right? So let's... not there. Here. I, in this case, returns the element in the collection, not the index. Some programming languages give you that. Now see, I set it, right, I set it up there to 111, and it's now returning ones the whole way across. If I do my for each again, after I've reset it, now it's 1, 2, 3. Yes, Dark Coder asks, can I provide the notebooks? There's the GitHub link for you in chat if you're watching this live on Twitch. If you're watching the video on YouTube, there's a link just below here in the description so that you can click through to the GitHub repository where all the notebooks are so you can try these out and follow along as well. There are ways with the new C#, the new C# 8 language features, I believe it is, where you can define a range and it will allocate a range, a counting range of values here. But if you wanted to initialize all with the same value, I'm forgetting how to do that right now. So we're going to have a session later on about C# 8 and C# 9 features, and I also need to put together an errata video where I go back and talk about some of the missing pieces in each one of these notebooks that we should go back and cover. So, all right. Some of the next collections that we would interact with. Array, in the chat room, Dom is saying you can use array.fill to set these all to the same value. Let's do this. Array.fill. So if we allocate my one array equals new int 3 array.fill, my one array 1. And they're all initialized to 1. Thank you, Dom. Appreciate the grab there. I knew there was a command to do it. I just didn't want to go digging and sorting through. Much appreciated from the chat room. All right. So, the next collections that I want to talk about are hash tables and sorted lists. Now, these are ways that you can create key value pairs with some sort of object as a key and some sort of object as the value. We're not explicitly declaring those. And they have a no duplicate keys, right? Keys are unique inside of these. This is a way for you to create that almost a linked list, right? A way for you to reference and maintain a collection of objects that you want to access very, very quickly inside that collection. So if I create a hash table here called file extensions, and if I add these 3 file extensions, txt, mp3, and jpg, with these descriptions, plain text, compressed music, and JPEG compressed images, when I use a hash table, these values will be sorted and stored based on the hash of the key, the first element, the first argument in the add method that's used to interact with this. So now if I save that, I get JPEG, text, MP3. And that looks weird that text comes before MP3. It's because the hash value is different. Now, when I interact with this, and I change this and use the sorted list, it stores these by sorting on that key value. And now you get it as our human minds would think, JPEG, MP3, text in alphabetical order. Okay, that kind of makes sense. There's a comment here in the chat room. I want to make sure that I highlight here, and I'll add this note into the text up here. When you use array resize, it does allocate a new copy of the array. Now, my understanding was because you passed it by ref, it changes and resets that reference to the array that it returns. So when I do array resize here, it changes this. So I used my numbers there. If I have a reference to that, it now points to the new reference because I've updated it. It's not passing it by value. So let me move on here, and I'll dig up and get some notes around that and make sure I update the notebook appropriately. Duplicates are not allowed inside of these, right? You can't have the same key listed multiple times, so I can't add MP3s also for sound effects. I've already got compressed music in there. The key's already in the dictionary, right? This kind of makes sense, right? That's the whole point of a key. It's a unique value. So I'll get rid of my error there. And I can access the items inside my dictionary by key here. So file extension, square brackets to access them. And now instead of passing an indexer, I'm passing that key value, MP3, and it'll return compressed music. I can also remove objects by key. I can interact with this and take a look at the length, and I can do that same foreach method to iterate over the collection inside of that sorted list. But when I do my foreach, I'm going to get a key value pair returned. Let's take a look at that. So if I do a, let me put this into code. There we go. If I do a foreach, and this is going to be a key value pair on file ext. So it's in file ext, okay? And if I say display kv.key, it's going to show me what those keys are. No. You should be showing me that. There it is. It's a key value. Now, why it didn't show me .key, I don't know. It should have given me that for the key value pair, but I'm clearly seeing key and value. Do I have to explicitly make this a key value pair? Nope. It's a dictionary entry. Aha. Aha ha ha. I have the wrong type. There we go. Now I can say .key and I get just the keys. So I'm interacting and I can work with those and format them and place them in different places. When I do a for each, make sure you know you get both elements of the sorted list or the hash table to work with. All right. Let me take a look now. We're going to talk about queues and stacks. So sometimes it makes sense to have a queue, a collection of objects that are accessed in, first out manner, right? This is like waiting in the line at market, right? Or waiting in the line to pick up your Xbox. Your first person in the line is the first person who's going to receive their Xbox, and they will depart the line, and then the next one, and so on and so forth. Instead of adding elements to it with some sort of an assign operator, we now enqueue and dequeue. That's not spelled right there. That should be not queue. That should be enqueue to add and remove. And you can also take a look using the peek method to inspect and interact with the oldest element in the queue. So those are the things that I can interact with. KRJax has a question backing up just a second here. Let me make sure I answer this question. When I was working with that for each loop, what type is it when I used var there? So I had var here. I can display that type by saying kv.getType, and it'll show me that that's a dictionary entry. So I need to make sure that I interact with those thinking it's a dictionary entry. Now, right, it didn't allow me to interact with it. For some reason, it thinks it's an object because it's generically an object coming out. But when I inspect and convert it, the strong type that it returns is in fact a dictionary entry, right? So I can convert it with the parentheses, and now I can interact with it, which feels kind of weird. That feels like a lot of work to interact with this, and that's a pain in the neck. So what we're going to see going forward, that, yeah, okay, add enqueue to add elements to the, yeah, I was right. I was right there. What we're going to see going forward with this sample is it's going to get a lot simpler when we start to deal with generics in the next set of samples that we're going to talk through here. All right. Now, I was talking through queues here. So I've created a queue here called my queue, and I'll create and add two strings to it, first and second. And I'll just output what the queue looks like, and there it is being displayed by the notebook for us. First and second, index 0, index 1. I can then use count to check the size of the queue, and it'll show me how many elements are in there. Okay, that's fine. I can peek to inspect the next value off of the queue. So if I say myQueue.peek and display it, I get first, because that's going to be the first element. It's the topmost element in the queue that's going to be removed. And now when I dequeue, when I take an element out of it, it's going to give me first. If I run peek again, now that I've dequeued and I've taken first off of it, come on now, show me these, right? It's going to show me first. I dequeue, it gives me first there. If I peek, it's going to show me, well, the next element to come off is going to be second. and I can DQ again, and it gives me second. If I attempt to peek again to say, well, what's the next value? Now I get an error. The queue's empty. So you need to be able to handle that peek. And there's I believe it's a try peek method you can interact with as well that won't throw an error. It'll tell you true or false whether or not it actually is able to handle that there is an element there for you to find. Zyva asks, what's the notebook software we're using? This is Jupyter Lab that I'm using, and there are links to how to configure this right there in the GitHub repository. Can you use add with Q is the question we have from Zamcat. So let me reload the queue. Get rid of that error. I don't want to see that error. And let's try using add. Third. Add isn't, and you use these two commands, inq and dq are the two that you use to interact with it. So there is a link to the complete documentation about queues right here, and you can see the methods that are available for you. You can't add, but it's DQ, InQ are the methods that you use there. There's peek. I'm not going to get into synchronized and threadings. So we can go through these and work with them as an enumerable. We can do a foreach on the queue as well. So if I change this to InQ, now I've got 3 elements. 3. It's the first, and there's the first element. So, you're welcome, Zyva. So there's instructions there, and there's even a Docker compose command and a Docker container that'll get this running locally on your machine. The binder software should be able to run this in your browser, but it looks like there's a little bit of a problem with them today, and it's just not quite launching right away for us. So the next collection to talk about, now these are just managing objects, is a stack. Now a stack I think of like a deck of cards. Last in, first out. Whatever's on top, whatever was put on top of the stack last is the first to be removed. So I have a deck of playing cards here. These are playing cards that I got from Scott Johnson. He's an artist here on, you'll find him on Twitch, you'll find him on YouTube. Let me see if I can get these open so we can talk about a deck of cards and talk through this just a little bit, because the interaction, I think, is a little bit more interesting. And these are sealed pretty good. I should have opened these ahead of the stream, you know what I'm saying? That's how you can tell this is live, because weird stuff like this happens. Alright. So this is a deck of playing cards, and these feature Scott's art on them. Right? So when we think about, right, we have a deck of cards, right? So the last one on top is the first one to pop off. And that's a how to play card, right? But there's other cards here, right? You can see there's a Joker and, right, all the different suits and whatnot. And, right, there's that stack that we're managing. Now, I'm going to create a stack here for my poker hand, because I'm a good poker player. And I'm going to put into my hand, I'm going to use a little bit of this card notation. I'm going to put an ace of diamonds, right? The rank dash suit. So, and these are just strings, right? Ace of diamonds, ace of spades, 9 of hearts, 9 of spades, 9 of clubs. I got a full house. That's a winner hand right there. Winner, winner, chicken dinner. I'm feeling pretty good about that. Russ Jr. in chat, he likes to perceive, Russ likes to think about a stack as a stack of Pringles. right? Thinking about the potato crisps, potato chips that you get in a can, they're all shaped the same way, and they stack nicely on top of each other, and you get them stacked coming out. Absolutely. I didn't want to make people hungry, and I thought cards were an interesting way to refer to that. So that's right, Kerjax. Pure skill that I got that full house, and a little bit of code. So if I take a look at that, and say, show me my hand, there you see it's got 5 elements in it: 9 of clubs, 9 of spades, 9 of hearts, ace of spades, ace of diamonds. Fantastic. Looks good. And I can pop then and say, well, give me the top item off of it. Notice, I pushed into the stack first the ace of diamonds, and I last pushed in the ace of clubs. I'm sorry, the 9 of clubs. And the 9 of clubs is going to be the first one to be retrieved when I run the pop method. So I get 9 of clubs out of it. Now, that's not bad, right? I can run pop again. I need to let that run, right? So there's my 9 of clubs. If I run it again, now I get the 9 of spades, now the 9 of hearts, ace of spades, ace of diamonds, and stack's empty. Your hand's empty. You played all your cards. So, very clear how a stack works, right? And cards, I think, are an interesting way to interact with this. And Janesco is spoiler alert, going right into the next issue here. These basic interactions that we've been talking about for arrays and right, stacks and queues, and our hash table and our sorted list. These are the all referring to just objects, and we need to respectfully interact with those objects and the types that are coming out of those collections. There's a question here from Zamcat in the chat room. Let's answer Zamcat's question here. What is the difference between a stack and a queue? This is what I was just showing, where a stack is that deck of cards where the last one that's added is the first one that's removed. A queue is first in, first out. So up here in my queue sample, right, I've added these 3 elements, first, second, and third, so they're added in that order. When I look at the first element to be removed from the queue using peek, it tells me the first element to be removed is going to be first. So the same order that they're added to the queue is the order they're removed, where stack, I've added ace of diamonds first, it gets pushed to the bottom of the stack, and the last element is the first one to be pulled off. Okay? So that's the difference between queue and stack, right? Is the order in which you access them coming out of there. There's a couple more questions about this. Let me queue these up. These are some pretty good questions here. Lophurt asks, can you pick any element from a queue or stack somewhere from the middle? No. That type of random access is why you would choose to use a hash table or a sorted array or an array, because you want to be able to have random access to things. If you need to do processing on some data in a specific order and you want to pull them out in the same order that they went in. And I see a comment here. Maven thinks of a queue as a line at a ticket booth, perhaps to go to the theater. Whoever got to that front of the line first is the person who's going to be purchasing their tickets first. And whoever got to that line last, they're the folks that are going to be purchasing their tickets last. They go through that line, right? Because you're standing on line, you're queuing in that order. So this is what Lophurt is pointing out here, is this is why you would choose to use one type of collection or another. Because you want to either have that random access, or you want to have that specified access so that you do fetch things in those orders. Okay? Good points there. Thank you so much for the question. Appreciate it. So I mentioned we've been just generically putting... Generic's the wrong word. We've been blindly putting strings into our stack here. And we need to appreciate that we're working with an object in there, right? It's storing an object on the stack or the queue or our hash table or sorted list. It's a sorted array, right? It's sitting out there, and it's not actually a string. It's an object that we're interacting with. And you can get into some hairy situations dealing with type conversions if you start to mix and match types for those keys and values. Frail Young asks, can you for each over a stack? Now, before I get into the type here, let's take a look at that. Let's do a for each over this. So there's my hand. It's loaded up with those values. And I believe I can also do a peek here and see, well, here's the next one that'll be popped off of the list. So if I want to do a for each, right? So let me do a for each here. For each var item in, and it's called my hand is the stack that we're interacting with. Let's just output item. Display item. So you can do a for each. It is enumerable, and it's displaying them in the order that it's showing. Now, after it's done displaying that, what happens when I say my hand dot peek? Now, I need to put a display command around that. So that for each is not taking them off of the stack, okay? It's effectively doing a peek and showing you each one of the items in the collection. When I run, right, my hand dot pop, this, let's say this card equals that, and I say this card, right, I get that item, and now my stack is one less. So for each is something you can do. It's not a good practice, right? The whole point of the stack is you want to just see the next item. You want to order these appropriately and interact with them in the same order that in the last in, first out manner. There's a question here from Spark of Shark, though, about that peek. Can you peek in at the nth item? No, peek does. I will confirm here. Peek does not take an index. It's strictly the object at the top of the stack without removing it. You can't go through and say, well, give me that one to interact with. So, good questions. Now, I mentioned about dealing with types around this. If I declare a type called card that has a rank in a suit field on it, and I'll create a constructor here just to make it easy to declare these things with a toString that casts it back to that same rank-suit notation. If I declare a stack for a deck of cards and I add an ace of diamonds, and a king of hearts, and then I add a joker card, when I can go in and push in another card there. I'll pass in the jack of hearts. When I first saw on a deck of cards when I was a kid a J in the corner, I thought it was a Jeff. And for a while I called that a Jeff of clubs, a Jeff of hearts, a Jeff of spades. So if I push in a Jeff of hearts, that's a thing. That's totally a thing. I made it a thing. And I execute this, you'll see, look at this. The type is a card, and then it's a string, and then it's a card, and then it's a card. I've mixed types inside of my stack. Consequently, then, when I take a card off of the deck, off of the top of the deck, right, I get a Jack of Hearts, a Jeff of Hearts. I now get, well, it's not a card, right? I'm trying to cast this as a card. It's not a card, so I get null. And then I get my King of Hearts and my Ace of Diamonds. So when you work with this, whether it's a queue, a stack, the hash table, the sorted array, right? That's what I was using. You need to be aware of those types as they come off of those, because it's being stored as just an object. And you can end up in this weird scenario where I can't interact with that. Now, there's a couple comments there about how you would use queues versus stacks and where they're each useful. Queue is very useful if you have a collection, if you have a set of work that needs to be done and you want to go through it and you want to work on it in that order in which they were first requested, first operate on. But a stack may be useful as well for, I'm using a deck of cards as my metaphor here for you to interact with. There may be other scenarios where it makes sense for your business logic to work with a stack of objects instead of a queue. Dacky Potato, yeah, you can do that, but that's and that's a link thing that we can get into either later today, next time. But that's you're fighting with the purpose of the object with some of that notation that you're using. You use a stack for undo. That's a great one, CSharp. If the stack is the list of actions that I ran through in my text editor, Visual Studio Code, or maybe in Microsoft Word, or some other productivity application, and I want to be able to do that Control-Z to undo my actions, well, the action that I want to undo first is the last action that I did. You don't want to undo the first action. So there's a good example of undo working. Okay. So clearly when we're working with these as objects, and if I try to work with this without doing that cast, and I start interacting with these, right, I have to cast it to a card in order to get a card object here. Well, if I make it a var, all right, now there's my Jeff of Hearts, right? But now, because I used var, well, var turned into a string, right? And now that could have unintended consequences later in my code, that now it's behaving as a string, not as a card object. And now it's a card again. So you need to be careful with how it's dynamically setting that type and interacting with it. Okay. There is no Visual Studio being used here, RP Cordy. This is all Jupyter notebooks with a .NET kernel. There's instructions there on the GitHub for how to use this, how to configure this. Now, if we want to force all of the types in our collection to the same type, right? We want to force all the elements to the same type. We want everything to be a card on that deck of cards. We can use a generic collection. So a generic is a way for you to force a type parameter onto that and specify it from client code. So we give this angle bracket T convention to specify the type of the parameter on a class or on a method, on something that we interact with. And then we can enforce with generic collections that all of the objects that are on my queue or on my stack are of that same type. And if you try and add objects that aren't of that type, it'll throw an error appropriately that says wrong type. And so we have a queue, we have a stack, there's a couple other generic collections that you can work with, but there's also list and dictionary that I want to highlight here and talk about. And these, to some of the folks in the chat room who are asking, well, I want to be able to randomly access some of those things. These might be more appropriate for what your architecture for your application needs. So let's talk about that. Let's talk about a list of T first. And that's how we read these generic types, right? This is a queue of T, right? A queue of some type. So I'm going to specify a list of T, and this is the most flexible of those collections. You can add, remove, and access objects randomly of whatever that type is. So we declared our card type earlier. So let's create a list of cards, not a deck of cards, because a deck is a stack, right? In the order that we put these on top is the order that they're going to come off of them. But clearly, if it's a list, well, I can randomly interact with the 10th card down and whatnot. So I'm not in queuing or pushing onto it. I'm now adding Ace of Diamonds, the Jeff of Diamonds. You're going to be calling it a Jeff of Diamonds and a Jeff of Hearts by the time I'm through with this video. A 9 of Clubs and an 8 of Spades. And if I look at that list, well, it's a list of card objects, and it has an index that goes with them. Once again, 0 base to that index. And they're in the same order that they're added to the list. No sorting. Okay, there is a sorted list that you can use that will sort. There's a sorted dictionary that you can use that'll sort as well, but there's no sorting or preference being given to this. So that list of cards is, right, that list of cards is, right, that var that's there is actually, and we can output this if I say list of cards dot get type, right, that needs to be a capital G. And I specify, let's display that. You'll see it's a generic list of type card, right? And there's my card class that we created, and there's the collection of those items. And I can access them randomly using that indexer. So if I want the third element, I use index 2, and it gives me the third element that was added, the 9 of Clubs. So these are the ways that you can interact with the list, and I know that I've always got a card object in there. KR Jax points out, see this, look. They keep asking the casino if they have blackjack tables. Hey! No. It's a blackjack table. Or 21. It's not blackjack. Sorry about that. Sorry. So I can access those randomly with that indexer, and I can insert into it. Add just adds to the end of the collection, but I can insert wherever I'd like into the collection another card. So I had Ace, Jack, 9, 8. Well, if I want to insert the 3 of Hearts, well, the 3 of Hearts here, insert it at index 2, not position 2, at index 2, and it pushes those other 2 items down, and it puts the 3 of Hearts in there. So with the list, I can randomly insert and access those values. That's right, there is an element at, so you can reference and get that index value as well. Let's add that here. And look, I'm gonna do the Joker example next. So if I say list of cards, index, right, element at, and if I specify that 3 of Hearts, right? Is it element at or index of? Why do I think it's index of? It doesn't see it. It doesn't, because it's actually a new object. let's call this 3 of hearts. Right, if I move this up here, and if I insert the 3 of hearts, element at will give you that item. I believe it's index of is what you were suggesting in the chat room. Right, so if I do that, what do you mean it doesn't exist? I didn't execute is what happened. There we go. Now it tells me it's at element 2. It tells you where in the collection that item is, and I've inserted it a couple times here. So if I go back and rerun some of this code, right, it's at index 2. You can clearly see it's at index 2. Element at, yes, returns what the item is there. So if we go back over here, we say list of cards, element at, and I specify element at 1. I forgot the semicolon. I need to do a display on these. No, you know what? No. Hang on. Let's do this. Let's split right here. Right, there's where the 3 of hearts is at. Element at I is the jack of diamonds. The Jeff of diamonds. See that? So. But it's the same indexer, right? Element at and the square brackets do the exact same thing. There we go. Does the same thing. Okay. Rats. Scrolled right off. See, this is where I edit things for the YouTube video. So now if we added a Joker, let's try and add a Joker card, and we're just going to add, we'll see, it rejects that and says, well, I expect a string there. It needs to be a card. You can't just add Joker like that. It doesn't work. So, these are, right, some of the trade-offs that you give up by making it a generic list. However, on the flip side, you end up with this strongly typing, and the compiler will help you, right? In your text editor, in your code editor, you'll get IntelliSense that will indicate that index of is looking for a card object to go find. Or, right, that when you call add, it's looking for a card object to add to this list of type cards. So, right, you catch that error before you do something that you shouldn't be able to do. Thank you, Dacky Potato. Appreciate the kind words. So, continuing on here. SOS AV9, welcome in. Hello. Thanks for joining us. Now, the next collection I wanted to show you is to show that you can actually take multiple types, multiple generic types, into a class, and this is a dictionary. So, in this case, I want to specify the type of the index, and I want to specify the type of the value. So if I go back to my file extensions example, I want to force the type of the key to a string, and I want to force the type of the value to a string as well, so I can now pass in plain text compressed music and JPEG compressed images, and I clearly see that they're not sorted, they're in the dictionary with the same values that they were added. Okay. Now, this means I can access them using that key as an indexer, right? And there it is, JPEG, and I get JPEG compressed images coming out of there. And I also, I can't add the same element, add an element with the same key that's already in there. You can't, just like I had before, you can't create the same thing. So that throws an error. And additionally, that typing on my keys is going to be enforced as well. You can't push a number into a string, right? Similarly, I can't make this a card and pass in a new card, the Jeff of Hearts. That doesn't work either. Okay. What do you mean it doesn't exist? There it is. Can't do it. All right. So these are important things for you to know, that you need to stick to the types appropriately. And that could be very convenient for you when you're building your software, writing your application. If you expect to have a collection of person records for your human resources application, product records that you're retrieving because you're building a shopping cart, and you want to ensure that all of those objects that you're working with are the same type, because you want to output data appropriately. You want to create that search results list on a web page because folks are searching for information about what Xboxes do you have in stock. So these are the things that you want to be able to consider and interact with as you write your code. All right? Now, what if I want to create my own generic classes? Now, this is great, Jeff. You're showing me the things that come in the box here. And like I said, there's a queue of type T and a stack of type T that behave just the same way as we saw those two classes earlier, but they force those types appropriately. What if I want to create my own generic types? So you can define a class, you can define methods that use that same angle bracket T notation, right? So I'm going to create a Fritz set of type T. You're going to specify that type later, and I'm going to keep an internal list. I'm going to manage and keep a collection internally that I'm going to actually interact with. Now, you can add new items to a Fritz set, and I'm going to constrain them to that type of T that was defined. So this T, right, whatever we put when we use this, and you see down here I'm using an integer, that type is carried through everywhere in the class that you angle angle brackets T. So I've specified that this is a class of type whatever, T, in this case integer. So when I use that angle bracket T notation here for this list, it carries through that integer so that this list is of type integer. And because I also use that T as the type for this method, the new item that's being passed in is an integer as well. So it's forcing this type on that. I'm going to queue up your question there, Killer McD, so I can get on the other side of this example, and we'll talk about this. And DNI stream is right there. So I have a new Fritz set, and when I add, you see here, I'm going to use a random number generator to randomly place items into that list, right? Because we saw earlier with my list object, my list generic collection, I can use the insert method to insert anywhere I'd like into that list randomly. So I'll use a random number generator to randomly insert 1, 2, 3, 4, and 5 into that list. And because I declared this is of type int, these are integers that I'm inserting, and if I execute this, you see it puts them in there. It's not sorted, they're just random in there, right? So every time I execute this with Control Enter, you see my numbers that are inside that set. They come out in different orders. 2, 4, 5, 3, 1, 5, 1, 3, 4, 2, 3, 5, 2, 1, 4. It's randomly placing them in there. And you can't, right? You can't, like I said, you can't put in a different type. So even if I make this 5.9, sorry, that's a double. And this takes integers. Rejected, right? And this is the power of putting generics on your own types where you want to enforce, hey, this is only taking this specific type. So in my code, I want to randomly put things into that list. So you're not allowed to change types on the fly on me. That's the closest I've gotten to that being in in the actual natural order. 1, 2, 3, 4, 5. 1, 2, 5, 3, 4. I haven't gotten it back to 1, 2, 3, 4, 5. But it's gotten close. So, the next example I have for you here is, well, what if I use that with cards, right? Clearly, this actually gives us a little bit of a shuffle type of operation, where I'm going to add cards into that collection, and when I execute these, you see there's my collection of cards that are being retrieved, and they're not in the same order that I put into them. I've effectively done a little bit of a shuffle every time I add them into my collection. So these are ways, right, that it does make sense to do this interaction. There's a couple questions in the chat room. I want to address those, and some of these are going to lead to a little bit of trial and error here, and we'll see if we can break some things. But that's the point of why I want you to be able to use these Jupyter notebooks, is you're not breaking anything. This isn't an application that's going to fail or crash. We can create errors here, and it's no big deal. We can quickly type some changes, execute that, and see what happens. The first question that we have here is from Killer McD, and Killer McD asks, how is a dictionary different from the other example that I showed with the file extensions? So the generic dictionary that we used, that we showed up here, right? This one is only stored by key, right? So there's those values, and they're stored in the same value that you added them into the dictionary. There is an insert method. You can insert these in appropriate order and move them around. This is more of a random access dictionary. We can store these. I believe there's a sorted dictionary that we can use here, and it will now sort them by the key value, right? The examples that we showed earlier up here were around, right? It was a sorted list in a hash table, and they sorted by the hash of the key or by the value of the key. So these are two different ways that you can store and interact with that data, where the generic one here, right, working with that generic dictionary, stores them just in the value that they're added. If you do need to sort them, use a sorted dictionary. There is also a hash set that you can use that behaves the exact same way, except there's just one value here. You don't have two. So, right, if I were to, let me go somewhere in here, right, right, if we have a hash set, right, oh, come on now, it's hash keys. That's better. That's what I'm looking for, right? And if we say var set equals new hash set of type, let's use the cards, right? Type or namespace, it should be a capital S, isn't it? There we go. So now I can say set.add new card, a Jeff of clubs, right? And if I just output the set, right? So if I add a bunch of these, right? Let's add an ace of clubs. Let's add a 9 of diamonds. I'm just picking values out here. And let's make this a 3 of hearts, right? They're sorted, they're added in there, right? And they're kept in a index. In this case, they're not ordered by the hash, but they're kept unique by that hash. So if I try and add another 3 of hearts, it actually should have. Now I'm blanking on the hash set. Ah, darn it. It stores and keeps these values by the hash value of them. And now I'm blanking on it. But generics, there's a very good statement there from DNI Stream. Generics for many developers is the preferred way to use this, so you don't end up passing objects around. I'll add a little bit more documentation around the hash set in the final version of these that we make available with the YouTube video. There's also a question here from Curious Drive. And Dacky Potato, that is a topic for a different time, but I think I want to add to the errata later. Is it possible to make a Fritz set of type object? Yes, but it kind of defeats the purpose of it. Consider, right, so there's my deck of cards, and we're going to get into LINQ next here, right? So let me clear this out so you can see where I'm working. So if I call this an object set, right, and I say new Fritz set object, right? I mean, that does work. Great, you created one of these, right? And if I want to output it, there's nothing there. I can add, right? New card, right? There's the object that's in there. That's great, right? But I can still add Joker. The whole reason of doing the generic is lost at that point. You've effectively, right, made the generic because any type will work with it. That may be desirable, but all of the compile time checking, all of the advantages you got from making it generic are now lost. However, this may be valuable to folks if you want to implement something that, right, if you want to use something that is a generic type and make it generic, you want to make it able to store and interact with any type. You can do that. Possible. Now, we've used the var keyword here. I've used static typing by declaring exactly what these things are. And there's a comment here in chat. I want to bring it up. That I want to make sure you can use a dynamic keyword that does all the type checking at runtime. This ends up being more like some of those other dynamic languages that we're familiar with. Ruby, Python, JavaScript have this feature, and it is available in C#. I don't want to go into this today, but I want to make sure that those of you who are watching, reading in chat, there is a dynamic keyword that you can use in place of var. We're going to cover this. I'm going to cover this probably in our errata episode, where I go back and I'll step through each one of the notebooks and go a little bit deeper on each one of those and add an extra chapter or two, an extra section or two at the bottom of those to kind of finish off those topics. So, all right. I'm just reading through chat here real quick. So, right, these are decisions that you make when you interact with, and if you're using C#, you want to be using that strongly typed, statically typed language so that you get compile time checking on some of these things. And when you make this of type object, the compiler isn't helping you. So you don't end up with that check until later on. So, let's add a note here. You can also force a generic type of object and lose that compile time type checking. And compile time versus runtime, because I'm running in the notebook here, is kind of lost. They both happen at the exact same time because of the interactive nature of these demos. So, yeah, we'll talk about dynamic another time. I don't want to confuse beginners. I don't want to go too far here off the deep end into things that I don't want to I don't want to confuse them. Now, the next section that I wasn't sure if I was going to get to, so I just left it blank and figured we could start here because my goal was actually to get into LINQ statements next time. But we've gone through this. We've had a very quick run through the samples today, so I'm gonna tiptoe into this, and I'll finish this out. The sections that we write here, I'll add some text. I'll add some appropriate links back to the official documentation, and we'll continue. We'll start on LINQ today, and we'll get further into LINQ next time in what will be notebook number 6 and session number 6 on the 21st of September. Now, LINQ is an abbreviation, and it stands for the Language Integrated Natural Query. And these are ways for you to query, to interact with collections using some more natural language interactions. And I'm going to focus on lambdas for this part. A lambda is a predicate. It is a method that goes at the end of a collection that you can use. It's a predicate method that you can use to interact with the set of objects inside of that. So let's work with that Fritz set for example, right? And I have the deck collection up here. I'm going to copy and make that same collection available down here. Let me delete that, and I'm going to paste in that same collection there. So there it is running. There's my deck collection. And I can start interacting with that deck by using the language integrated natural query. Yeah. So you can use this to interact with this. Now, of course, the collection itself has a I'm sorry, that's a... Oh, Fritz set doesn't have a count. Right, if I look at the inner object, right, there is a count there because the inner object I know is a list, right, because I declared that up here. I can access that. But I can interact with that in several different ways using these LINQ predicate methods. So not only do I have a count property, there's also a count method that I can interact with. Now, these are ways, right? And you're right there. These work on enumerable collections, right? Things that we can go forward and interact with. You can, right, execute these methods, and it will act on each one of the items. Some of them will interact with some of the items. Some will skip and omit even looking at some of the items in the collection. But these objects need to implement either enumerable or queryable interfaces. And we'll go further into queryable next time. But that's right, Space Shot points out there, that enumerable interface, IEnumerable interface, unlocks this capability. So does iQueryable. So I've got a count method here. Well, I can now say things like, well, I don't want to just count. I want to count those cards that are diamonds. No, wait a sec, how do I do that? I could put some sort of a for loop, and if the suit is a D, I can interact with it, but I can also use an expression body member here inside that method as a method argument to interact with it. So I'm going to generically refer to the card object inside of that inner list as C. Use a fat arrow, so C, such that now I can inspect that card object. So I can say, well, let's look at that card suit, and I want to return true. I want to include it in my count if the suit is diamond. Now when I run it, I get a 2, because there are only 2 diamonds inside the deck of 5 cards that I added, the ace of diamonds and the 9 of diamonds. And the count method that I'm using here only counts those values where what's inside this expression is true. Okay, so count is called a predicate because it's added on to the end of this, and that we're counting, right? We're counting cards where the suit is diamond. I can also turn that around and say, well, give me the count where it isn't a diamond, and now it's 3. I could do things like say, well, you know what? Let's count where the rank is greater than or equal to 10. Now that's weird because it's a string. So it's kind of hard to do. But, right, this is effectively the counting cards type of interaction that you might do if you're a good blackjack player, right? So you need to be aware of the types when you interact inside of here as well, right? So greater than or equal doesn't work, but if I say give me a count where the rank is 10, doesn't work. I can't do int parse either, because that could be an ace. I almost need a value. Right, if I create a value for my card, I'm going to go up to the card class where I declared a card up here. Right, there we go, card. Right? So if I create an, we'll make it a byte. We'll call it value. Right? And we're going to say, we can put in a ternary expression here that says, well, if rank, how do I want to do this? Because there's things here that if the rank is ace, I want to return 1. This could get a little dicey. This is going to be a lot here to actually calculate those values. I'm going to come back to this. I'm not going to go into that further because that's going to get a little messy. But we've done our count here. If I want to count where there's aces, there you go. I've got 1 ace in there. Sure, we could do an int try parse and try and cast things over, but we're still going to run into an issue there. Exactly, Space Shot. So we've done count here with this, right, with this query to say, well, count those items. I don't have to necessarily count with that expression, right? Let me change that back over to where the suit was diamonds, right? Get the 2 items out of that. Maybe I want to actually see those. I can, instead of using count, I can use the exact same expression body member, and I can say, well, show me where they're diamonds, and now I get a new collection being reported that has those two values. Ah, okay. Those 2 cards reported. So now I've got another collection being returned. I can clearly, let's keep track of some of the things that we've gone through here, right? So I've been able to count and do that. Well, not only can I say where and take a look at the contents of that, I can now run count on that and see there's 2, right? I've created, I'm chaining together these various predicates. because where returns another IEnumerable collection, I'm now saying, well, take that IEnumerable and count the values that are in it, and I get 2 returning. I can still do that same type of approach here, where I can say, well, count where the rank equals ace, and now I get, right now it's saying find me all the cards where the suit is diamonds and count those diamonds that are aces. And there's different ways now to interact with that. You're right. Numfish points out in creating that card type, I could have declared the rank as an enum. I could have also made the suit as an enum, one of the 4 suits that we have, right? Diamonds, hearts, clubs, spades. I could have done that. Easier just to make it a string for the purposes of readability. So different ways now that we can do the same thing, but we're chaining these together. There may be times when you're passing this collection from one method to the next, and sometimes you want to simplify and do that count directly and force that where clause, and maybe you want to separate it and work on that collection and push things around. You're getting way ahead of me there, Space Shop, but thank you. Yes. So I'm filtering with where, right? I've clearly taken this, right? And I'm filtering out exactly those objects that I want. Now, I'm returning cards because that's the object of that's in my deck, are cards, right? That's a collection of cards. But I can also now map. Maybe I know that these are diamonds that are being returned. I just want the ranks of those. I don't need to see the individual cards. I don't need to see the entire card. So I can use a method now called select. And select gives you a way to specify it gives you a way to specify what type of object you want to return from that. So at its very simplest, I can say, well, take that card that you're looking at inside that collection and show me the rank. And now when I run it, I get the 9 and the ace. I know they're diamonds because I ran that filter previously, but I'm getting just those being returned, and they're in a collection now. And it's a collection of type string, right? Say it's a collection of type string. All right, now it's a select iterator. It's an IEnumerable with a select iterator, right? And we'll talk about iterators as we get further into LINQ next time, because there's interesting things going on there. I'll get into select many next time. That's a way further down here. So I'm able to select out those various ranks, and it returns as a collection of strings. Okay. So let me add some more cards into the collection here. Let me put some more into the mix here, so that this makes we get a little bit more interesting bits here. So I'm going to add some of the rest of the diamonds into the mix. So there we go. We should have 5 ace, 6, 7, 4, and 9. All right. So now they're being returned to me. Yeah, group by and some of those others we're gonna get into next time. They're gonna do some very interesting things. Yes, you can add some duplicate ranks. This is just a list. It's not a dictionary, right? So I've got duplicate cards in there, right? So these are ways that, right, I'm interacting with this, and I'm selecting out, I'm just returning that collection. But Let me see. Let me get rid of the one spade that we have here. So there's also ways that you can test and return by doing some sort of an inspection and saying, well, does anything in the collection meet this criteria? Right? So I can interact with and say, well, does anything... Do you have any spades? False. There are no spades in the deck there, right? Okay, right, and this is, right, the any is effectively like playing Go Fish. Do you have any spades, right? Right, maybe to truly be like the game Go Fish, the rank, do you have any queens? Right? The Go Fish game. So, any inspects the entire collection for that criteria and returns immediately true or false. But it's inspecting every element. It's doing, underneath the covers, a for loop and running that test every time until it runs into one of those values. Consider if I change this to a 9. As soon as it hits that new card 9 of diamonds right there, it's going to return true and not look at the rest of the deck, the rest of the collection, because it found one of them. And do any of these have that value? True, it found it. It doesn't need to execute and look at any other elements of this. I tell you, chat room is they're kind of reading, well, what's the next item? They're seeing, hey, this is what Fritz is going to talk about next. I see what you're doing there. So let me change that back to queens. Similarly, you can do the all and say, do all of these meet this criteria? So I can say, take a look at all of them, and right, are all of them diamonds? Do you have a flush of diamonds? Right, are they all diamond cards? No. But, right, if I go up here, I take the heart and the clubs out, and let's take out that heart card. Yes, they are. I do have a flush of diamonds at that point. Now, I went through and commented those out, but remember, you can chain these statements together. So I can do that where statement ahead of time and say, right, go get me where the suit does not equal clubs. Right? And I can even add another one that says where the suit does not equal hearts. Now they're all diamonds. I don't have any spades in the collection. So, right, these are, you see, we're chaining these together. Right? You can add additional where statements, or just like I have and we learned in our conditionals, and I see chat room, KRJax, and DNI stream say, well, you can also do double ampersand there. And it chains together those tests. So it doesn't do the complete filter on clubs, give you back the collection without clubs, do the filter again. It's doing one filter and running through that. So KRJax asks, do you prefer two where clauses or using the double at the and else operator there? I like using this if I don't need to return an intermediary collection. If I need to return an intermediary collection and I need where I don't know what else I'm going to conditionally add on to there, I prefer to make it one test that I'm executing through, so I'm only running through the collection once. When you start adding many different clauses here, now it gets into more and more processing that it's doing. So we want it to finish those tests as fast as possible so that we can do our final interaction. So you need to manage the number of trips through the collection. All will go through every element in the collection and run that condition. And right, I don't even have to add a condition there. All needs a condition. Right? Any doesn't need a condition. Right? Get rid of that comment. Right? All needs a condition. Any does not. Any returns true if there's any values in the collection. Right? Doesn't necessarily need to test those. So, and the bots are reminding me, friends, if you're new here, if you're watching the Twitch channel for the first time, and you want to be notified next time there's somebody on who's doing some educational content here on the Visual Studio channel, make sure, or our community stand-ups with our different product teams, make sure you click that follow button. It's right over here. It's a little heart button here on Twitch. Click that button and you'll be notified either by email or by notifications inside Twitch when you're watching other Twitch channels when the Visual Studio channel goes live. If you're watching the recording and you're over there on YouTube, click the subscribe button just below me here. Click that bell. You'll be notified every time that we release a new video here, or when we do live streaming on YouTube, you'll be notified when that starts. When you click the subscribe button, you click the bell there, you'll get those notifications immediately. Now, there are some folks here talking about when you chain predicates. Yes, they are only executed once you call the iterator. Once you call something at the end that forces a calculation. Whether it's count, it's select, it's any. When that execution takes place, it goes through and executes all of them in one shot. Alright. You can also put, and we'll talk about toArray and toList another time. Next time, there's nothing going on. There's more things going on there that I want to make sure we cover and get into that. Then. Lophert. Lophert has a question here. Hey, can you say hi to my wife, Emma? She says that I pay more attention to Fritz than her. Hey, Emma. It's Jeff here saying hello. Lophert, I'm sure that's not their real name. Good to see you, Emma. Hope you're having a great time. Emma, are you learning a little C# too? Let me help you out. Let's get in there. The family that codes together stays together? Is that the way that goes? Is that the way that goes? How's it going there, Emma? Chat room, let's all say hello to Emma. Hi, Emma. Everybody say hello to Emma. The family that writes code together, compiles together. There you go. There you go. Everybody say hello to Emma. There, see that? There we go. Look at that. Emma, so good to have you joining us. Appreciate you hanging out there in chat with your husband, Lophert. I'm assuming husband. So good to see you. With your partner, Lophert, I should say. You see this? Look, there we go. The couple that writes code together, updates Visual Studio together. Yeah, those happen. So, yep, and they restore from NuGet together. Absolutely. So, all right. So we've gone through. We've talked about some of these that let you interact with some of these predicate methods that are available to you in LINQ, and I'll add complete documentation here into the notebook before it's released out to YouTube. So if you're watching the YouTube video, the notebook looks a little bit different from from what I'm showing here, but it has all of these samples in it. But there's other things that we can interact with and we can do with LINQ to make these things interesting. It is possible to write your own extension methods. We'll talk about that next time. We can talk about ways that we can take a look at different elements inside that and work with collections from that deck of cards if we'd like to. So if I want to take the first element out of that, right? Out of that deck of cards, I can just say first, and it'll give me the first card, which is now the 2 of clubs is the first one that it gave me because it inserted them in random order, right? Because I have that deck add method that I'm using. Fritz isn't interesting. What? Don't make me break out sound effects. Don't make me break out them sound effects. I will take it. We're gonna break all this right in here. So I'm pulling the first item out of the deck. Well, it's a 4 of diamonds. It's a 7 of diamonds. It's a 3. I'm not always going to get the same item out of there. And as people are pointing out, there's other ways that we can wander through here and interact with this. So, yeah, Space Shot, I'm going to add links to the official documentation when I finish off this notebook and before we publish to YouTube. I always like to add those links to the official .NET documentation in here. So, if I want to pull 2 cards, right? I can not just say first, I can say take. And I can specify a number of elements to take. And it will now give me 2 cards. Maybe I'm playing Hold'em, and you're only dealt 2 cards. So now I'm taking 2 cards out of the deck. Okay? Maybe I don't want the first 2 cards because, as you see at casinos and other places, they do what's called burning the card, right? So when they're looking at the deck of cards, well, you might know what that card is. You might be able to see, you might be able to tell what this card is. So they take that first card and discard it, and then they give you the next 2 cards. So you can also skip and say, skip that first card and take the next 2 cards. And this is handy if you have, maybe you're not dealing cards to friends playing poker or at a casino or someplace. Maybe you're getting a collection of objects that you want to display on screen and you want to be able to page through it. So you want to skip a certain number of elements that you showed on a previous page. Take the next page of elements to display on the next page. I'm dealing cards here. I'm discarding the first card and taking the next 2 off of it. So these are ways for you to query and interact with those objects. And right, I've taken 2, but you also want to be able to do right. So we've skipped, we've taken some items through here, and right there, these are different things that right. I'm trying to think of some of the other collection methods off the top of my head because I didn't do any research. I'm literally writing this as I go here. Chat room. So we did skip. We did take. Well, what if I want to make sure I always get those aces up at the top? Right? Maybe I want to make sure I always get the aces, or maybe right. It's not horse. The low. Oh gosh, what's it called? The poker variant where you always want the lowest cards, the lowest values. Right? I want the 2, 3, 4, 5, but I don't want them in that hand. Low ball. There we go. Right. You can order by before you start interacting with these. So what I can do when I interact with my collection is I can say order by, and by default, it's going to order by the value of that. Right, so now if I say order by take 2, well, I need to give it how to order. What exactly are you ordering by? I'm going to order by the rank, right? So now 2 and 3, because that's the lowest value, are what it's going to go, right? Order by is smallest to largest, so I've got 2 and 3 of clubs there, right? If I say, you know what, go and grab up to 10 elements, so 2, 3, 4, 5, 6, 7, 9, ace, jack, okay? But this, we can make a little bit smarter, right? We can say order by, well, if the rank is ace, ace is actually the highest value. So let's tell it that ace is actually ZZ. Otherwise, use that rank value. Now it pushes the ace to the bottom. So the lowest value card, the 2 is at the top, and the ace is at the bottom. But I really want the ace at the top, because I want to take the ace first. So you can change your order by statement, and you can use the order by, is it order by descending? And now it changes it so the highest values are first, and the lowest values are at the end. So now we've effectively created a cheat operator, right? Take the first 2 cards. Hey, look at that, I got an ace and a jack. That's a pretty good hand. That's going to get me set up here. Or if I had multiple aces, right? It doesn't matter that that deck was shuffled. I got 2 aces. I got the ace of diamonds and ace of hearts. I got 2 red aces. That's pretty good, right? So that order by has put these in the order that I wanted. And if I go back to here, right? I'm getting 7 and a 6. I'm getting a 4 and an ace, a jack and a 4, a 5 and a jack, right? 7 and a 4. These are terrible hands, right? Oh, there were 2 4s, 9 and a 6, a 3 and a 7. I mean, a 3 and a 2, you might have a shot at a straight, right? But these are ways that you can interact with your collection to manipulate it to suit whatever your need is. I don't care about the rest of the cards in the deck. I want the 2 highest values that are available. Boom. Done. Not bad, right? So now there's questions and comments there about doing then buys. So once it's been sorted in one direction, right? You see, I'm getting diamond and heart, and maybe I want hearts first, right? Let's put all 4 aces into the deck here, so that I'm sure I always get them. There we go. So now I got a spade and a diamond and a club, spade and a heart. I'm not always getting the same one here. I'm gonna wrap this so I can make it clear. There's ways to take that ordered list and then sort by another value, right? And this is where I always get confused. So if I say now sort by suit, I'm now always going to get the club and the diamond first, right? I could do then by descending the same way, and I'll always get the spade and the heart because it sorts them in that appropriate order. So now I've chained together sorting of my objects. That's pretty cool. That's a great way for me to interact with these. And we're going to talk more about LINQ next time. So much to do here. I have so much fun writing this code with you. And those of you that are watching over on Learn TV, we'll see you next time. Thank you so much. Let me head back over to chat those samples, all the information, all the notebooks are available on the GitHub website. There's the link in chat. If you're watching the YouTube video, it's just below here in the description. You can click through there, you can click the binder link, and you'll be able to run these in your browser. There's instructions even if you want to be able to run all the samples locally. I had a great time talking to you today about collections, arrays, generics, and we even snuck in a little bit about LINQ. I'm going to finish and I'm going to format the rest of that notebook, edit this video, and make it available. I'm going to publish it over on the YouTube channel a little bit later today, probably tonight. I have a day full of meetings that I need to attend to. But I really appreciate all of you tuning in, watching this video. Make sure you subscribe to that dotnet channel over on YouTube, because we're going to continue to publish more of these videos for you to see over there.